So we're starting chapter 5. We're going to be looking at exponents and polynomials. Exponent rules can be confusing, so you got to make sure you sort them all out. The rules aren't difficult. You just need to be clear about what the rule is and when to use it. Okay? So we're going to start with a product rule, and if we have a base x, the rule says x to the m times x to the n is equal to x to the m plus n. Okay, so if our bases are the same and we're multiplying those bases, all right, with where they're raised to exponents, we can add the exponents. All right, so for instance, if we've got 5 squared times 5 cubed, then that's just going to be 5 to the 2 plus 3, or 5 to the 5th. Yeah, I mean, I would probably go on and use the calculator to find out what this is. And let me 5 to the 4th would be 625. So 5 to the 5th is 3125. Okay. All right, so 3125. Okay, here we just have variables. So we got a to the 7th times a to the 4th. This would be a to the 7 plus 4, or a to the what? A to the 11th. Okay, we got n to the 17th times n to the 45th. So this is going to be n to the what? 62nd. Very good. All right. Okay, in D, we've got multiple terms or factors. These are factors, not terms, because they're separated with multiplication. But we can still use the rule. So in this case, we're going to have x to the what? Very good. Because remember, the exponent on that last x is understood to be 1. So if we add 8 plus 6 plus 1, we get 15. Okay. All right. In E, we're starting to mix things up a little bit, but we can rearrange these factors. It doesn't matter which order they're in. So we can say x to the 6th times x squared times y to the 5th times y to the 8th. And so we get what? Very good. Okay. All right. Looks like, is F the same thing? Okay. F was the same. All right. G, it still works here. Okay. We still have the same base, right? We've got a base of 4x plus 1. We're multiplying, so we can still add the exponents. We get 4x plus 1 raised to the what? 21st. Questions about that? All right. So then the question is, does the product rule for exponents apply to x plus y squared? No. Okay, it does not. All right. You're probably already familiar with having to FOIL this out. That's what we would have to do. So be careful about that. That's a common mistake that that is made, is to distribute that 2 to the x and the y over addition. But there's not a rule for that. We can only distribute. Well, we'll see that a little bit later. We can do it over a product, but not over addition. Okay. All right. Very good. Okay, so we have a power rule where we have a base that's raised to a power, and then that piece is raised to a power. So it looks like this: x to the m raised to the nth power, and so we're going to get x to the m times n. Okay, we multiply the exponents. All right, x to the m times n. So if I have x to the 4th raised to the 6th, that's going to be what? X to the 24th. Okay, b to the 14th raised to the 4th. Okay, b to the 56. All right, and then we got 2 to the 5th raised to the 2nd is what? 2 to the 10th. And 2 to the 10th is, okay, very good, 1024. Okay. Questions about this power rule? All right, so now this is where it gets interesting when we start combining these rules. Okay, we've got x squared to the 8th and x to the 5th cubed. So we're going to get what first? Okay, x to the 16th. Okay, and then also x to the 15th. And now I can do what? Add the exponents. So we get x to the 31st. Okay, questions about that? Okay, why don't you try E on your own? All right, so for E, we get a to the 6th times a to the 35th. Now we add those exponents since we're multiplying these bases. So we get a to the 41st. Okay, how many people got that? Okay, good. Questions about that? Okay. All right, our next rule is power of a product rule. And this is the one I was mentioning just a little while ago. It says for any bases x and y, if we have the product of x and y raised to the nth power, then this is going to be x to the n, y to the n. Okay, this is when I can distribute that exponent to the things inside of parentheses. Notice here that we're multiplying x and y, not adding. Okay, so if I applied that here, this says 7m cubed. So this is 7 to the 3rd times m to the 3rd. Okay, 7 to the 3rd is 343. Very good. M cubed. Okay. All right, we've got the product of A and B raised to the 7th. So we've got A to the 7th, B to the 7th. That's it. Okay. All right, what about in C? We've got -5 n to the 6th. So what do I need to do? Okay, so that's going to be -5 to the 4th, and then n to the 6th to the 4th, and then -5 to the 4th is going to be what? 625, very good. And then n to the 6th to the 4th is n to the 24th. Okay, questions about that? Okay, good. All right, we've got a cubed, b to the 11th, all of that raised to the 5th. So we get a cubed to the 5th, b to the 11th to the 5th. Okay, and that becomes a to the 15th, b to the 55th. Okay. All right, questions about that? Okay, in E, we've got 3 factors, 2, x to the 5th, y to the 6th. So we're going to write this as 2 to the 8th, x to the 5th, to the 8th, y to the 6th to the 8th. Okay, and then we can reduce those from there. Okay, 2 to the 8th is what? 256, okay. And then x to the 5th to the 8th is x to the 40th, and then y to the 48th, right? Okay, questions about that? All right. F has a lot, but I think you can handle it. So why don't you try F on your own? Okay. How many people got this? All right. Questions about this? Any questions? Okay, so just remember, if we're distributing that exponent across, you know, things inside parentheses, we need to have a product, not a sum or a difference. Okay, we can distribute the exponent across a product, or we're going to see here in this next rule, we can do it with a quotient. Okay, we'll see that maybe a little bit later. All right. Okay, so we have our quotient rule. If we have the same base x, okay, we can write or reduce x to the m over x to the n by subtracting the exponents. So we get x to the m minus n. Okay, x to the m minus n. And of course, this works for all real numbers except x equal to 0. Okay, it doesn't work for 0. Then we also have the 0 exponent. If we have a real number, x not equal to 0, if it's raised to the 0 power, then we say it's equal to 1. Okay, x to the 0 is equal to 1. All right. So let's say that again. Yes. Well, we don't have 0. This could be some real number. Let's say it's 5 to the 0. Okay, that's going to be equal to 1. 5 to the 1 is equal to 5, right? So 5 to the 0 is equal to 1. Okay. Okay.
Well, I mean, we can memorize it, of course. It's just weird.
Let's see.
I would think if you had zero units of 5, that would be 0.
Well, but it's not. We're not multiplying. We're raising it to a power. So there tends to be a pattern. Let's say we have. I think it's easiest kind of to see it with tens. If we have, let's say, 10 cubed, that's 1,000, right? 10 squared is 100. 10 to the first is 10. So you see we have a pattern, right? We're losing those zeros. 10 to the 0 is 1. Okay. And any number except for 0 raised to the 0 power is equal to 1. Okay. All right. So let's see if we can apply some of that. We've got x to the 8th over x to the 5th. So I'm going to subtract my exponents. And we get x to the 3rd. Notice about this quotient rule that when we do the subtraction, our result is in the numerator. Okay, you don't see a numerator really, but of course we can always say that this is over 1. That's going to be important when we go on a little bit later. Okay, we got x to the 32nd divided by x to the 4th. That's going to be what? X to the 28th. Very good. We subtract the exponents. Okay. Z to the 36th divided by z to the 15th is z to the what? Okay, 21st, is it? Yes, 21st. Okay, very good. We just subtract the exponents. Okay. All righty. Okay, in D, we have a binomial, but it's the same on the top and the bottom. So we're going to use our exponents rules. We can subtract, and we get what? Okay, 2x minus 17 to the 6. 11 minus 5 is 6. Yeah. Oh, that's okay. All right, 5 to the 0 is 1. Okay. What about negative 8 to the 0? Negative 1. Very good. The 0 is only on the 8, right? So the negative is still out there. 8 to the 0 is 1. So negative 1. Well, we could go on and multiply it out more, but we've not talked about that in this course yet. So there's no, based on what we know and what we're talking about now, there's no easy way to do that. Remember I said you can't distribute that exponent over a sum or a difference. So yeah, so that's what's going on. We're going to leave it right there for now. Okay. All right. What about 4 over 13 raised to the 0? 1. Very good. Just 1. Okay. What about all of this raised to the 0? 1. Very good. Okay. Now we've got several factors. What can we do with this? Okay. So 28 over 7 is 4. R to the 3rd, because we're subtracting the exponents. Since they're the same, yes, if we subtract it, we'd get what? S to the 0, which is just 1. Okay, we might write it there just to be clear. And then t to the 3rd. All right, but because this is s to the 0, we don't even need to write it. So it's 4r cubed t cubed. That's our final answer. Questions about that? Okay, we've got power of a quotient rule. Okay, and so we've got x over y raised to the nth power. And the rule says we can distribute n to the numerator and denominator. Okay, just like we were able to distribute it to each factor in a product, we can do it to the numerator and denominator for a quotient. Okay, so for any basis x and y, x over y to the n is equal to x to the n over y to the n. And that's it. Okay, we're just going to leave it at that for now. Okay, so if I wanted to apply that here, we get x to the 7th over 2 to the 7th. Okay, and 2 to the 7th is what? 128. Okay, so x to the 7th over 128. All right, we've got x over y to the 12th. So this is x to the 12th over y to the 12th. All right. Then we've got m to the 9th over n to the 6th, all of that raised to the 8th. So if I wanted to show all my work, I would say m to the 9th raised to the 8th over n to the 6th raised to the 8th. We distributed the exponent to the numerator and denominator, and now I can use my power rule. We get what? Over, or times, no, over n to the 48th. Very good. All right, m to the 72 over n to the 48. Okay, questions about that? All right. We've got x over 5, y to the 9th, all raised to the 5th. And then we've got 17x to the 5th, y to the 19th, z to the 24th, over 32, a to the 11th, b to the 70th, c to the 33rd, all raised to 0. Okay. Let's do this one first. What are we going to get? 1. If it's all of that's raised to 0, we don't even have to worry about doing anything. Of course, we can't do anything on the inside since we don't have the same basis top and bottom. But even if we did have x, y, z's in the top and x, y, z's on the bottom, because of that 0 on the outside, it's just 1.
So if it wasn't a 0, it was just any other number, then it would stay the exact same way it is because we can't do anything to it right
That's right. Yep. There's nothing we could do to simplify the inside the way that it is right now. Okay. All right, and over here, we get what? X to the 5th. Okay, 3125, because that's going to be 5 to the 5th, y to the 45th. Okay, questions about that?